We'll now look at section 5.3, where we will talk about logarithmic functions and their graphs. Let's begin with a definition of a logarithmic function. Let a be a fixed, positive, real number not equal to 1. The logarithmic function with base a is defined to be the inverse of the exponential function with base a and is denoted log base a of x. In symbols, if f of x is equal to a of x, then f inverse of x is equal to log base a of x. Now there are several things in this definition that we want to make a point of pulling out to be sure we understand. The first thing is that a log function is the inverse of an exponential function. That relationship is going to help us as we work problems and also help us as we work on graphing logarithmic functions. We also want to keep this in mind, that if f of x is equal to a to the x, then the inverse is equal to log base a of x. And we're going to use that specifically in just a minute as we look at a graphing example. So let's begin here. They're asking us to sketch the graphs of the following logarithmic functions. The first one is f of x is equal to log base 3 of x. Now, the issue is that our calculator does not allow us to input a base 3. The calculator will allow us to graph base 10 and base e, which we'll talk about in a little bit. But those are the only two that the calculator will graph. So if we have a base 3, then we have to figure out another way to graph this. So what we're going to use is this idea of the inverse. So we're going to come back and we're going to say that if our function is log base a of x, that is the same thing as that's the inverse of a to the x. So if this is our function, then we can say that the inverse function is going to be 3 to the x. Now, granted, on our definition, we had the fx and the f inverse reversed, but it doesn't matter. What matters is that these two functions are considered to be inverses of each other. Now, 3 to the x, we talked about graphing in the last section. If you recall, we did a table of values. We selected some very specific points, and we plugged those points in for the x in 3 to the x. So we said, plugging in 0, 3 to the 0, anything to the 0 power is 1. 3 to the first is equal to 3. And 3 to the negative 1 is equal to 1/3. And we worked through that in the last section. And then we went to our graph and we plotted those points. So we plotted the point 0, 1. So I'm going to do that here as well. Here's 0, 1. We plotted the point 1, 3. And we plotted the point negative 1, 1/3. And we connected those dots. And we drew this function 3 to the x. Now, the idea is that the log function that we're being asked to draw here is the inverse of the one I just drew in green. So remember what that means in terms of what happens when you go from a function to its inverse. Remember that the x's and the y's switch places. So if I'm going to plot this function, instead of having the point 0, 1, I'm going to have the point 1, 0. And instead of having the point 1, 3, I'm going to have the point 3, 1. And instead of negative 1, 1/3, I'm going to have 1/3, negative 1. And so you can see that those 3 points have been plotted on the purple graph, and the purple graph has been drawn through those 3 points. And that is the graph of your log function. Okay, so we're going to do the same thing for part B. We are going to use our definition, and we're going to say that we know that the inverse function, if we have log base 1/2 of x, that the inverse function, and then I guess there will be a g here. So our inverse function would be 1/2 to the x, which again is a function that we drew in the last section. And even if we didn't, we could easily come in here and say, okay, let's pick some very specific points. Remember, 0, 1, and -1 are always easy to evaluate. 1/2 to the 0 is 1. 1/2 to the first power is still 1/2. 1/2 to the -1 is going to cause the 2 to move to the top and become 2. And so I could come to my graph and I could plot those 3 points, the point 0, 1, the point 1, 1/2, and the point -1, 2. And I could connect those points. And this is the graph of G is equal to 1/2 raised to the x power. And again, if we're going to graph the log function, remember that it's going to be an inverse. So we can use these same points, but with the idea that the x's and the y's switch places when we go from a function to its inverse. So 0, 1 becomes 1, 0. 1, 1/2 becomes 1/2, 1. -1, 2 becomes 2, -1. And again, you can see those points plotted in purple and connected. And that purple graph is going to be the graph of log base 1/2 of x. Okay, so we can further expand on that just a little bit in terms of our graphs. And they're asking us to do an additional example, and they're saying sketch the graphs of the following functions. And so the first one is log base 3 of x plus 2, and then it's got a plus 1 tacked on the end. So let's talk through what changes this is going to have. Now we know that it's going to be based on the graph of log base 3 of x, which we just drew. All right, but how's it going to be changed? So the fact that we replace the x with an x plus 2, remember that causes a left-right shift. And because it's plus 2, that causes a shift to the left. So the graph is going to move left 2 places. And then what does this plus 1 do? The plus 1 tacked on the end is going to move the graph up 1 unit or 1 place. All right, so let's take a look at our graph and see if that makes sense. Okay, so here we go. The graph in green is the original graph. All right, so this is the graph of log base 3 of x, the one that we drew on the previous example. Now, we said that the graph needed to move to the left 2 places. So look at your points. We're going to move these points to the left 2 places and then up 1. All right, so we are going to go on this point. We're going to go, that's 1 right there. That's 2 right there. And we're going to go up 1 and it sits right there. So that's the first point. This one, over 2 to the left, up 1. There's the second point. And over 2 to the left and up 1, there's the third point. And we connect those points and we have our new graph. Okay? All right, let's go to example 2. Example 2, we have, actually let's go to example 3 and we'll come back to 2 in just a minute. Okay, so example 3 is going to be based on the function log base 1/2 of x, which we also drew on the previous example. And then how does it change? The only change that we have is the -2, which is going to cause the graph to do what? To move down 2 units. All right, so when I work this one out, I'm going to take the graph that we drew in the previous example, which is the dotted green line. All right, so this is the line, this is the graph of f of x is equal to log base 1/2 of x, and we're going to move everything down 2 units. And so take it point by point. Here's the first point, we're going to go 1, 2. Here's the second point, we're going to go 1 unit, 2 units. Third point, we're going to go 1 unit, 2 units. And then we have the purple graph that we can connect those dots and draw our graph. All right, and then finally, let's go to this middle one. All right, so part B is the basic graph is f of x is equal to log base 2 of x, which we haven't drawn, but we can. All right, and then let's think about how it's going to move. So the x has been replaced with an x minus 1. Now we still have to deal with this negative that looks like it's been distributed through. All right, and we'll deal with that in just a second, but let's first of all consider the fact that this x got replaced with an x minus 1. All right, so when that happened, what did it do to the graph? It moved the graph to the right 1 unit. And then what happened? Then this negative came into play, and basically it looks like they took this x and they replaced it with a negative x. So what happens to the graph when you replace an x with a negative x? That graph reflects over the y-axis. So we're going to move it to the right one, and then we're going to reflect it over the y-axis. All right, so let's look at this one. All right, so the graph in green is the graph of log base 2 of x. Now, again, this is not a graph that we have drawn yet, but it would work just like the other 2 examples. So we're going to go ahead and assume that we have that one right. And then remember that our graph is going to move one place to the right, and then it's going to be reflected over the y-axis. All right, so let's take it a point at a time. So 1 unit to the right, this 2, 1 is going to go right here, and then it's going to flip over here. And this 0.10 is going to move 1 to the right, and then it's going to flip over the y-axis here. And this 0.12 negative 1 is going to move 1 unit over, so here, and then it's going to flip over here. And again, we connect those 3 dots and we form the purple graph that we were asked to draw. So that gives us an overview of graphing logarithmic functions. As we get further along with this, we're going to learn some other techniques that we can be using to do these graphs. But for now, this helps us in being able to draw the graph of a logarithmic function.